Alright, we're going to talk about variables and expressions, and we're going to do some work accordingly with these vocabulary words. A variable. Basically, a variable is a symbol used to represent a quantity that can change. Alright? A constant is a value that does not change. Numerical expressions contain only numbers and operations. Now remember, it's an expression, not an equation. And then an algebraic expression contains at least one variable. It can have more than one, but it has to have at least one. And then when I say to evaluate, that means we're going to plug a value in and we're going to determine or calculate the numerical value. Now let's draw some examples of a few of these words, okay? For instance, a variable is a symbol, okay? That little word right there. So it could be an X, it could be a Y, it could be, let's say, an R, an M. It can be any letter. But you know what? It says a symbol, so that means I can even use a heart if I wanted to. If I wanted to use a little asterisk, I could also do that as well. A constant is basically a value that doesn't change. Well, it could be a 3, it could be a 5, 17, maybe even a -1. But these are numbers that won't change. I mean, a 3 will always be a 3. A numerical expression, only numbers and operations. So 3 plus 2. 1 plus 6. These are numerical expressions. An algebraic expression has have at least one variable, x plus 3. Now let's add two variables. How about x plus r? Or 6 minus y. These are all algebraic expressions. And then finally, if I were to evaluate, let's say if I had 2x plus 3, and I wanted to evaluate when x is equal to 1. Well, I would simply plug it in. 2 times 1 plus 3 would give me 2 plus 3, which is 5. Okay, in this section we're going to translate algebraic expressions, and if you notice in these boxes up here, what we're going to do is we're going to use these words instead of add, we're going to use these words instead of subtract, these for multiply, and these for divide. Now remember, adding means put together or combine, subtracting means that you're going to find out how much more or less. Put together, or multiply means put together equal groups, and then divide means separate into equal groups. Okay? So down below is where we're going to do our work. So write each algebraic expression in words. So x plus 3. So we're adding. So I'm simply going to write x. Oops, hold on a second. We're going to write x and then plus 3. You could have said 3 increased by x, or x increased by 3. On the right hand side, m minus 7, since we're subtracting, we could say 7 less than m. That's one way of putting it. Another way, we would say m minus 7, or the difference of m and 7. Remember, you always state this one first when you're doing it that way. 7 less than m. 2 times y. Well, we can say the product of 2 and y. Or we can just say 2 times y. K divided by 5, we could say the quotient of k and 5, or we can simply say k divided by 5. So now, you've got 4 down below. Here's a subtraction, this means division, addition, and multiplication. So you try it. In this particular section, we want to translate from words to algebraic symbols. So, for instance, in the first one, Eve reads 25 pages per hour. Okay? We want to convert that we want to write an expression for the number of pages she reads in an hour. Well, in this particular case, 25 pages per hour. Therefore, we will just write it as 25h, and we're going to let h represent the number of hours, like it says right here. On the second one, Sam is 2 years younger than Sue, who is y years old. So y belongs to Sue. Write an expression for Sam's age. Well, if you think about this, y is equal to Sue. All right? So that's Sue's years. Now, Sam is 2 years younger. Well, if you take away 2 years from Sue, you will have Sam's age. And therefore, y minus 2 is the expression. In the last one, William runs a mile in 12 minutes. All right, so we want to write an expression for the number of miles that Will runs in m minutes. This is sort of like the same as in A. Well, if he runs 12 miles every minute, we would get 12 times m, or 12m. Now I want you to try it on your own. So look at here, I'm going to kind of help you out here. In this first one, Lou, let me go ahead and increase this. Lou drives 65 miles per hour. You need to write an expression for the number of miles that Lou drives in t hours. So that means you've got to use the letter t. In the second one, Miriam is 5 centimeters taller. Well, what does that imply? Does that mean you're going to add, subtract, multiply, or divide? So Miriam is 5 centimeters taller than her sister, who is m. Now remember, that refers to the sister. So m is the sister. So how are you going to represent Miriam being 5 centimeters taller? And then finally, Elaine earns $32 per day. Write an expression for the amount she earns in D number of days. So you're going to use the letter D in the expression. Okay, in this next section, we're going to be evaluating. Remember, evaluating is you're going to find the value. So in this case, we're going to evaluate each expression when x is equal to 8, y is equal to 5, and z is equal to 4. So anytime you see an x, a y, or a z, you're going to replace them with these numbers. Okay, let's take, for instance, A. It's x plus y. Well, x is 8, y is 5, and so when you evaluate those by plugging them in, you get 13. Now, x divided by z. Well, in this case, it's 8, and z is 4, so 8 divided by 4 is 2. So now you're try it. Now look at number 1. It's mn. What does that mean? Does it mean multiplication, division, subtraction, or addition? In this case, it's m times n. On number 2, it's p minus n. And then on number 3, it's p divided by m. Notice p divided by m is the same as saying p divided by m. Both of those are the same. Now it's up to you, again, to plug in those numbers and to evaluate. In other words, you're going to find the answer. Now let's try our hand at an application problem. Approximately 14 20-ounce plastic drink bottles must be recycled to produce 1 square foot of carpet. So that means for every 1 square foot of carpet, you're going to have 14 plastic bottles, 20-ounce plastic bottles. So it's 14 bottles per carpet, or per square foot of carpet. And if you recall some of the things that we wrote earlier, well, now you have something to think back on. It's 14 plastic drinking bottles per square foot of carpet. Well, if we follow this general rule of thumb, if I plug in a 1 here, you'll get 14 times 1, and that's 14 bottles. If you want 2 square feet of carpet, again, you multiply that times 14, and you get 28. So this rule applies. So this expression right here is the rule that we're going to use. In B, we want to find the number of bottles needed to make 40, 120, and 224. So what we're going to do is, our rule is 14C. So we're simply going to plug this in. So 14 is going to remain the number of bottles that we need for every 1 square foot of carpet. So now what we're going to do is we're going to multiply it by how many square foot of carpet we want. So if I multiply this accordingly, so I get 14 times 40, which is 560. So it would take 560 20-ounce plastic drinking bottles to create 40 square foot of carpet. Now, if I do 14 times 120, well, that means I'm going to need 1,680 bottles. And then if I do 14 times 224, well, then that's going to make me use or require me to use a whopping amount of 3,136 20-ounce drinking bottles to make 224 square feet of carpet.